Alright, so today we're going to look at factoring. We've gone over this before when we did the review of previous skills, but we're going to start to need it more now, so let's just go over it again. We're going to go over taking out common factors and then factoring some trinomials, some simple trinomials. Okay. And then tomorrow we will go into more tricky trinomials. Okay. I'll review decomposition tomorrow, and I'll also teach you another method which you can use. But for common factoring, all you're going to do is, for example, let's look at this example. Let me zoom in a bit there. Okay, so you're going to look at all the terms and say, okay, well, what's common in every term? You can start by looking at the coefficient. So here we have a 6 and a 9. So what's the greatest common factor that we can pull out there? It would be a 3. So we'll pull out a 3. Here we have an x squared and an x. So x is the greatest common factor, and a y squared here, and just a y. So again, y is the greatest common factor. Okay. Then we need to ask ourselves, okay, 3xy times what gives us 6x squared y? So again, let's start with the coefficient. 3 times what gives you 6? That would be a 2. X times what gives you x squared? That would just be an x. And y times what gives you y? Well, that would just be 1, but we're not going to write 1. And we're going to do the same thing over here. Remember, this negative is part of the coefficient. So we'd have 3 times negative 3 gives us negative 9. X times what gives us x? That's just 1. And y times y gives us y squared. So that's the first one. Okay. Now the second one looks like a tricky trinomial. Okay. But what we're just going to do is pull out a common factor. That should be the first thing you do when you're trying to factor any question before using decomposition or any other factoring technique. First, see if there's a common factor that you can pull out, because if there is, you can make the question a lot simpler. And in this case, there definitely is. I mean, not an x, because here we have an x squared, an x, and we don't have any x term. However, 12, 4, and 16 all have a common factor of 4. So we can pull out a 4. 4 times 3 gives us 12. 4 times 1 gives us 4, but I'm not going to write the 1. You don't need to write 1x. And 4 times 4 gives us 16. So that's pulling out, well, it's still a tricky trinomial, but that's a lot simpler there now that we've pulled out the common factor. Alright, so a couple more examples. So in this case, you can probably see that each coefficient is divisible by 3. Looks like that's the greatest common factor, so we'll go with it. If it's not, that's okay. We'll just see that there's more things we can factor out. But we'll start with the 3, and that'll be x squared minus 3x and plus 4. And it looks like that's as far as we can go. With this one, the coefficients, it doesn't really look like there's a greatest common factor. Well, there is, it's 1, but we're not going to pull out a 1. However, this has an x squared and this has an x. So we can pull out an x, or a 1x, but again, I'm not going to write the 1. And then that'll give us brackets of 5x plus 3. So I'm going to pause there and let you try question 3 on your own, and then we'll take it up. So for C, when you're looking for a common factor, you could notice that the brackets are identical. So the brackets themselves appear in both terms, meaning they're a common factor. So we can take that bracket and take it completely out. Okay. And then what do we multiply that by? Well, for our first term, it would be this bracket multiplied by 5a. So we put in 5a. And for the second term, it's plus this bracket multiplied by 2. So we take that 2, put it there. Alright, so now we're going to move on from common factors, and we are going to look at factoring simple trinomials. So here we have a quadratic equation in standard form. So ax squared plus bx plus c. What we're going to do is factor it into what we call factored form or intercept form. We'll analyze this form later in another chapter, but for now we want to be able to go from this to this. Okay, now in this case, today we're going to leave the value of a as 1, so we call that a simple trinomial. Like in this example here, right, that would be 1x squared. And then the value of b is a positive 2. It's that entire coefficient, so positive 2. And the value of c, again, is negative 8. It's the entire coefficient. That negative needs to be with it. So negative 8. All right. Now, how are we going to do this? Let's look at an example that we don't have the answer for. Down here, we have x squared plus 11x plus 30. So what we need to do is find two numbers that multiply to give us our c coefficient. In this case, c is 30. And we need those same two numbers to add to give our b coefficient. In this case, b is 11. So you can try a couple different numbers. I mean, you can try 10 and 3. Those multiply to give you 30, but they add to give you 13, not 11. So something else you could try would be maybe 5 and 6. 5 and 6 multiply to give you 30. Right? And it's very important that those same numbers, 5 and 6, must add to give you 11, which in this case they do. So the numbers we're looking at is 5 and 6. So we're going to write two binomials in brackets, where the first term is going to be x, and the second term, one is going to be 5, one is going to be 6. It doesn't matter what order you write it in. You can write plus 5 here and plus 6 there, or you can write plus 6 here and plus 5 here. It doesn't matter. If you're ever unsure, what you can do is expand. Right? So we've factored. What we can do is now use FOIL to expand and make sure we get that same quadratic that we started with. So let's double check this. Here we have x plus 5 and x plus 6. Right? If we FOIL, we get x times x, which is x squared. We get x times 6, which is 6x. We got 5 times x, which is 5x. And 5 times 6, which is 30. Right? Then we collect our like terms. So we have 6x and 5x, which add to give 11x. All right, so that's a good confirmation if you're ever unsure. Are there any questions? All right, so let's try another example. So in this one, we need two numbers that multiply to give us negative 28. Remember, that negative is part of the coefficient. So two numbers that multiply to give you negative 28. And that should be a hint that one of the numbers should be negative and one of the numbers should be positive. Now they should add to give you negative 3. Okay, so if they add to give you negative 3, the larger number should be more negative. So in this case, you can try a couple, maybe 4 times 7. One of them needs to be negative. Let's make the bigger one negative. So negative 7, let's just write this down here, negative 7 and 4. They multiply to give you 28. Okay, but when you add them, you get, oh, I got it on my first try. You might get lucky like that sometimes, right? So that works. So you can write x minus 3, x minus 7 and x plus 4. Right? So they multiply to give you 28. They multiply to give you negative 28, and they add to give you negative 3. Right? But it really is a guessing game. The more you practice it, the better you'll be at your guessing, but really it is a guessing game. You'll guess one thing, it might not work out, so you'll try two other coefficients and try it again. But one tip that I can give you I already mentioned this, but always, 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 before you start trying to say, for this example, what are two numbers that multiply to give 98 and add to give 28? First of all, that strategy won't work because this is not a simple trinomial. The value of a here is 2. But second of all, those are big numbers to be messing around with in your head. So the first thing you should always, always do is look for a greatest common factor. And in this case, these are all even numbers. So let's pull that out first. Pull out a greatest common factor, and we're left with a simple trinomial, one that's a little bit easier to work with. Okay, so try this one on your own and try finish this one on your own, and then we'll take them up. Okay, so now that those are done, there's one more thing I wanted to mention, is you'll probably notice that these brackets are identical. So what we can do is simplify even further to make the equation look a little nicer and write it like this. Because also when we write it like this, right now it looks like vertex form of a quadratic, doesn't it? It's just plus our k value is 0. And so that's a form we are more familiar with at this point. And so that'll be it for